has held academic positions at Spelman College and Fayetteville State University, together with visiting associate professorships and adjunct positions at a number of very prestigious universities. He's held several summer faculty research positions at government labs, including NASA Langley, and he is a condensed matter physicist. He doesn't look too condensed to me, but that's dealing with density functional theory in solitons, electro-optics, pyroelectric resistivity and dielectric properties of crystals and nanoparticles, doped organic thin films, sorry, nothing about the organ there, and STEM education. He has many publications. He is guiding currently 2 PhD students, and I assume several master's students he doesn't mention. He's received grants and honors, and is founding director of IHSER, the Institution of Higher Science Education and Research. He's been a guest editor for the American Journal of Materials Science and sits on the board of directors of 3 science journals, 1 science education journal, and is a member of the executive committee of the Alabama Academy of Science. Dr. Evans.
So thank you, Dr. Malo. My mother would be very proud of your presentation. Could not have been done better. Yes, that's what it's all about. So it is my pleasure then to have a moment to share with you some thoughts that I've had for many years now. You can see by the gray hair, I've been in this business now 40 plus years. The science education portion is what I'm about this morning. There's a quiz at the end of this too. Constructivism, I've been with this word now for 5 or 6 years. I was with Bloom's Taxonomy first, then with the affected domain secondly, and then I decided that both disciplinary and interdisciplinary study. All of these facets are needed for what I'm trying to do with the students that I teach on a regular basis. And also this has implication for the research portion as well. So let me go on now. So in academia, the benefits of critical thinking occurs effortlessly for a large segment of students, some of which are my physical science graduate students, engineering students, and physical science majors. And I'm not intentionally leaving out others, but these are the people I deal with mostly. The rewards of critical thinking develop slowly, if at all, for a large remaining segment of students who often don't form what I call mental structure or word association. This is a very elementary presentation, but it goes to the core of my greatest concern for the last 25 years plus now. So the onset of cognitive thinking, I believe, began with simple memorizing, recording, valuing, comparing, and contrasting events. And go on here, and then once you have some of that and you add Bloom's taxonomy, Bloom's domain, you're able to move on with constructivism and mental mind structure and association without even thinking of that. The able-bodied student does that. He or she developed a knack for critical thinking while other students remain languishing in a state of what I call inaptness. So what we have done, we've taken the idea of constructivism and added then these simple things that we do automatically. Develop mnemonics, acronyms, with what we call mental hooks, mental straits, mental S's, mental wave pattern, and word association processes to assist students in learning new concepts at the beginning level. It's at the beginning level that concerns me. So here we are then. I'm going to have this little outline. I'm going to go through, I just went through the abstract, go through some introduction. Then I'm going to go through a series of illustrations on constructivism and the way we're using it. And there'll be some final thoughts and literature cited, acknowledgement. Okay. These are my students. These are my students. I've had them all of this 40 plus years.
I have the same ones.
These are yours too.
They're at university.
Yes. And it's this student that has my greatest concern. I want him to get like her. And I see him now mostly in my physical science classes. I don't see him in my upper level physics classes, in my quantum mechanics class, mathematical methods class. This is the person I invariably see. I see this person in my lower level physical science class that I have asked the university to let me teach that class because I want to get to know this person and what is his issues in terms of why I can't get him or why he can't get over there. I'm sorry, some of these are double slides. So critical thinking then is that mode of thinking about subjects, content, and problem in which the individual improves the quality of his thinking by skillfully analyzing, assessing, and reconstructing. So keep the image of those two people in your mind. Now, mental structures then, as a set of techniques, are the basic mental processes people employ to make sense of information. And these can be grouped in three interdependent categories. Comparative thinking structures we call, symbolic representation structures, and logical reasoning structures. My wife is here with me on this trip, and recently we were at North Myrtle Beach in North Carolina. And there's North Myrtle Beach, and here there's Melbourne Beach and Cocoa Beach. And it seemed as though Melbourne Beach is not nearly as populated as Cocoa Beach. And North Myrtle Beach is not as nearly populated as Myrtle Beach. So she quickly did the logical reasoning in comparing Melbourne to Cocoa Beach, North Myrtle Beach to Myrtle Beach. And this we do all the time, and it's just a part of thinking and processing. Now, I'm going to use this symbolic representation structure here a lot today. Now, so I started with Bloom's taxonomy. For my upper level classes, I realized I only needed to talk about Bloom's taxonomy. Just give those students knowledge, comprehension. They will do the application. They can do the analysis, the synthesis, evaluation. No problem. No problem. But then when now when I got to teaching, when I became teaching Physical Science 102, I began to realize that receiving the information was an issue for the students. Responding to what I am teaching became an issue. Valuing it, and that I think is the core of much of the issue for lack of my ability to transfer what I'm teaching over to the student. And organization, you have to organize the information, and characterization as well. So I began to realize that the affected domain, if the student can't appreciate the affected domain, he or she cannot get to the cognitive domain. It took me many years to get to that level of reckoning, but I got there. Now, the disciplinary learner is obviously steeped in the tradition of a given profession. He or she is able to solve problems and make products, participating and maintaining and elevating that discipline, desiring to preserve its methodology, principles, and practice that my colleagues spoke of so elegantly this morning. They're able to conduct research as scholar professional doing, depending on their level. Now, this is also the interdisciplinary, who I think is very important in this, has synergistic connection between aspects of two or more disciplines to solve world problems. And he or she is able to solve problems, make products, expanding into understanding, connection, etc., and participation in maintaining and elevating the discipline, and also desire this. Now, constructivism, this word, and then mental mind structures and association. Learning is not just a mechanical process. We all know that here. The received information must be valued and processed. This word valued again. Some researchers have had the misconception that students could be receptors of knowledge rather than active learners. And it can be argued that constructivism, in my opinion, can provide the foundation that guides the entire learning process of new concepts. And mental mind structures or cognitive structures and word association enable learning. This is key. So mental structures here. Mental structures are used to create meaning and processing information by making connections, by finding patterns. Very elementary for everyone in this room, but not so much for some of the students I'm teaching. Identifying rules and structures and abstracting principles. Now, I've taken this from psychology. I'm not a psychologist, by no means. But my point is, it's not the discipline that's significant, it's the structure that I'm arguing that's significant. I have here top, bottom, left, right. Very simple. This is a very active person at the top, a less active person at the bottom. And these are what are called unpleasant emotions. We all have them. You can be tense, nervous, stressed, upset, sad, depressed, bored, fatigued, etc., etc. Now, a student gets this the first moment, and I want him or her to retain this. Not even mention going deeper into what all this is about, just retain this structure here. So, for me and for you, I believe we will say there is an association across. There's a horizontal association. A person can be tense, but on the better side of being pleasant, not tense, but just be alert. So there is this horizontal connection that I see in my mind that you can see in your mind. So as opposed to being depressed, just be serene. So this is going from an active person at the top to a deactivated person at the bottom. So this is just this. Now, how to retain this quickly? If you notice, I have just simply highlighted the first letter in each word. Because once I get these connected, and I have this horizontal structure in my mind, that I know every time I think about tense, I'm going to also think about alert. If I can connect these, then I have the whole structure. So I'm sorry, this is too much. So this is my first hook. Tense, nervous, stress, and upset. So what I've done is just, it's just taken this acronym and made a physical structure of it. No big deal. We see NASA all the time. We make these acronyms. And NASA makes sense. This one does not make sense. But TNSU, I will remember this structure. And because I remember the structure, I remember now that tense is there and alert goes with tense. Nervousness is there, and then excited is better. Stress is there, but as opposed to being stressed, just be elated. And upset, you can be happy. So I have the first level already with a hook that I call it. And I'm going to teach some of this. I'm going to find, even if I have to do some of it after class, for this student who was on the left-hand side, he's not unintelligent. That's my point. He is either unwilling to process or he or she is missing some critical issues in getting from the beginning to the next level of learning. That's been my experience. So this is my first illustration. This is at the bottom there, and so that there goes on. Sad, depressed, bored, fatigue. So that's just an idea. And this is then the acronym that goes with that. Now, clouds. I teach this in my physical science class. There are 10 basic clouds. No big deal. There are 3 high-level clouds, and clouds are no more than water, the drops of the water at low level, and ice at high level. But all of the high-level clouds have this word cirrus in it. So there's cirrus and cirrocumulus and cirrostratus. 3 clouds at the high level. All of the mid-level clouds have the word alto in it, so alto cumulus, alto stratus. And the low-level clouds, there are 5. 5, 3, 2. You would be surprised how many of my students fail this after I have taught it over and over again. And they will not remember that alto is what? Mid-level. And there's a structure from top to bottom here. So once you can begin to appreciate that we're just in height here, and then so they have this nice picture here, and so you can see this on the internet. But these are the 10 basic type clouds that we see. The most villainous cloud here is this alto cumulus, and it is a deceptive cloud as well. A dark alto cumulus implies tornado is, the very bad weather is approaching. But if it's a light color cloud, silvery gray, it portends fair weather. So the color of the cloud has a great to do with it. But it's not so much the specificity of these. It is the structure that's important as far as retaining all 10 of them and keeping them in the right order. So I wanted to share that with you. This is another one from organic chemistry that I get in this physical science classes. There are 4 chief classes of organic compound in living matter. The nucleic acid, the proteins, lipid, and carbohydrate. No big deal. So I'm not asking you at the moment to just absorb how many proteins there are, what's the chemical structure that they are, the fact that lipids are made by the body from carbohydrates. They contain carbon, hydrogen, and oxygen. Just know all 4 of them exist as classes of organic compound. So for me and for you, you would create some structure. Naples and NAPLC, NAPLC, nucleic acids, proteins, lipid, and carbohydrates. I will never forget that because I don't have the specific words floating around in my mind. I have them tied to a structure. I believe if I can get students to create their own structures and tie the overall issue together, they can make sense of this, and I will see my left student move to the right student we saw earlier. Another one from organic chemistry, I'm sorry. There are these 6 functional groups: the hydroxyl, the ether, aldehydes, carbonyl, carboxyl, and esters. Once again, he's CCE. That's just mine. But the other student can create his own. But I know that the pattern is hydroxyl, the ether, the aldehyde, the carbonyl comes before the carboxyl and the ester here. So I have these structures. So once again, these are now just word associations that I believe that if they are implemented in a concerted way with a valueness for the subject, the student can attain it at the introduction level and then move on to appreciate it more greatly as time go on. 1 or 2 more here. Now, from my, this is a physics calculus kind of thing. The integral, the sine of theta d theta is minus cosine theta plus c. All right, so there are four equations here, and notice there's a minus sign that has to go there. So my point is, if you retain that this one yields the minus sign, then you know the other 3 without much effort. Once again, it's order and pattern and structure. So I have thoroughly committed that every time you do this integral, the integral sine theta, d theta is negative cosine. That's a critical negative sign. Leave it off and it's totally wrong. But that negative goes there and the negative's there, but there's no negative in those 2. Point again, just word association, a pattern or structure allows you to keep the whole thing. This is another case here from quantum mechanics. I teach this class on a regular basis, and I have a graduate student working on this as well. So here again, a structure and an association. The most fundamental and the most elementary of these is the Schrodinger equation. But it is missing some critical things. If you include the fact that the electron has a spin, then you must go to the Pauli equation. If you now want to go from the elementary to the relativity, so the upper level are relativity based on Einstein principle relativity, and these are classical equations on this level. But you can go here to this level without spin, and you have the Klein-Gordon equation, and then you can go there to the ultimate Dirac equation that contains spin and the whole thing based on quantum theory here. So one can go here, go there, but you have this structure that ties everything together. I'm not asking at this moment, I say, for you to know how to solve the differential of the equations, and these are they. Here, these are this is the Klein-Gordon equation here, the Schrodinger equation, the Dirac equation, and this is the Pauli equation here. The simplest one to solve is this equation here. It's this particular equation. It has no relativity term. This term here gives the relativistic term, and this term here gives spin, that there has spin. The structure let you keep everything together. One more of these, and then I'm going to come to an end. From space science, we know we are all climate change. What's causing climate change is a big issue that's in the news now. Obviously, it's there. There are then three, okay, the sun energy varies in about an 11-year cycle. We know that as a fact. But these other three are the ones that cause extreme climate change. It's these other three. Do I only have two? Oh, I'm sorry. These other three, 1, 2, 3, are the ones that cause extreme climate change, the ice age, etc., has come about because these three. And notice I have here periodic change that occur in the tilt of the Earth axis, and I'm emphasizing T, the time of the year when the Earth is closest to the sun, that's an important factor, and the change in the shape of the Earth orbit from a low value from a circle to the ellipse, and it does that. But this is just a straight T, 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 S, T, T, S. So this then is time, tilt. This is shape and the change that occurred. That helps keeps that together. Finally then, constructivism, creating information in the mind, not just having it poured there, it is a valued, sorry for the misspelling, it is a valued method for critical thinking and learning. Constructivism, mental structures may be grouped in three interdependent categories as we indicated, and those are the three. The idea of mental structures such as hooks and straights, and I showed today a hook and a straight. I did not show S's, but you can easily conjecture how that would come. And word association, all under symbolic or coding. This is a code. So all those are codes, more or less, that I just put there. Create codes in your mind that you can retain. Then you have a better handle of the information. So these are gaining importance for helping the unachieving student retain new concepts. And so these are some literature citations here. All this will be Ms. colleague Dr. Agarwal and F.F. Jenin and NASA research. NASA supports my educational research and my scientific research as well. And I thank you.